And welcome everybody to the Daily Space Weather. Welcome to the star of the show, the Sun. If you'd like to leave a comment for the Sun, please leave a comment in the comments section. I'm your host, Dan, aka smAsho, and we'll be blasting through a ton of information once again today for the Daily Space Weather video. We'll be talking about a solar filament, about magma viscosity, leptons. How about a muon conflict? Yeah, we're going to the subatomic world. Here's the quite macroscopic world. Little active region in the northeastern limb of the closest star. By the way, all these images come from the SDO. So this is how the SDO is able to provide those images. It's on a figure-8 style orbit just north of the equator, around this area right here. It does this sort of figure-8 orbit here, right over this area. And that's where we get these great images from. Here is another composite image, the colorized magnetogram and ionized iron. The 171 angstroms ultraviolet UV emissions. And we see 0 sunspots, quite low levels of solar activity here. However, some filamentary behavior. Here's the non-colorized magnetogram. And we'll show you a couple more views before we blast through an insane amount of data. Here's 193 angstroms, some diffuse coronal holes, especially in the northern hemisphere, rotating in. The most defined one is ahead of that active region and that filament. Here's a great view of the filament. And that motion you see there is a calibration maneuver by the SDO to make sure it's pointed directly at the center of the solar disk. Here's 171 angstroms. And we've got some more close-ups of that active region to show you at the end of the video. For now, let's continue on, as there's more than enough interesting stuff to talk about in the meantime. First, your planetary diagram, as the Earth is opposing Venus right now. And there's where things will be in 1 week on April 15th. Here's a star chart for you. If you want to make your own, head to in-the-sky.org. And we'll be bringing up Cygnus X3, otherwise known as Deneb, later in the video. That star right there, the tail of the swan. The solar 10.7 centimeter radio flux currently at 76 solar flux units. It's the radio emissions from the upper chromosphere and lower corona, the corona being the sun's atmosphere. And here's a 1-year chart of that. The black line up there is the radio flux. The red line down here is the sunspot number. And we see some geomagnetic unrest forecasted, and we've actually seen some geomagnetic unrest happen. So we saw an unexpected coronal hole wind stream showed up yesterday, and it behaved pretty much exactly as expected. Here's the Noaa Forecasts, and we're seeing currently a heightened solar wind speed, which is what propelled it. There's Venus, by the way, on the LASCO C3. And there's another chart comparing sunspot number with radio flux. Ionosphere has opened a third fissure, and it's now filling a second valley with lava. Now, the lava coming out of Ionosphere is extremely it's runny. It's not viscous. What's the opposite of viscous? I can't think of the word. Anyway, here's a live cam of Ionosphere. Here's a nighttime image, and you can see it's slowly filling up its crater valley. There is an interesting story here about the viscosity of lava coming up and how its predictability via earthquakes could actually forecast some aspects of volcanic eruption. So here's this third lava stream unleashed. This is a phys.org article. Phys.org in the Earth section. Some great aerial views here of the cinder cones and fissure system. And this article here has, it just got published yesterday on April 7th. Earthquakes indicated magma viscosity during Kilauea's 2018 eruption. So I had part of this highlighted here. Let me read this excerpt for you. We show that the orientation of fault plane solutions, which indicate a fault's orientation and sense of movement for earthquakes preceding and accompanying the 2018 eruption, indicate a 90-degree local stress field rotation from background, a phenomenon previously observed only at high viscosity eruptions, as noted in the paper below, and never before at Kilauea. Experimentally obtained viscosities for 2018 products and earlier lavas from the Pu'u'o'o vents tightly constrain the viscosity threshold required for local stress field reorientation. We argue that rotated fault plane solutions in earthquake swarms at Kilauea and other volcanoes provide an early indication that unrest involves magma of heightened viscosity, and thus real-time monitoring of the orientations of fault plane solutions could provide critical information about the style of an impending eruption. Furthermore, results provide insight into fundamental nature of coupled failure and flow in complex multi-phase systems. So very interesting there, folks, about the viscosity and predictive value associated with seismic volcanism, volcanic seismicity. Let's see what volcanoes are erupting now. Fagradalsfjall certainly is still erupting. And here's a great aerial view. You can see the way it's filling up its crater valley. Super interesting. And low viscosity lava. Very low viscosity, to the point where it's only 1% thickness. So it just lays down like a very thin liquid, folks. It's like, I don't know, like maple syrup. Suwanosejima is also erupting. 9,000 foot altitude ash plume above it at the Ryukyu Islands. Sinabung on Sumatra, flight level 100, it's a 10,000 foot ash plume. 7,000 foot ash plume over Dakono on the Isle of Halmahera. Popocatépetl, sporadic emissions and mild explosive activity. Down there near Mexico City. Pacaya, volcanic ash not observed. Let's hope people's houses still aren't being destroyed by Pacaya, as they were a couple days ago. Fuego in Guatemala, exploding mildly. Nothing like a mild volcanic explosion. Anyway, sporadic emissions of ash, no flight level listed there. Sangay, the Ecuadorian Sangay volcano, flight level 180 over Sangay as it explodes. It's an 18,000 foot ash plume. 14,000 foot ash plume over Revenador as it explodes, and intermittent emissions from Sabancaya are a reminder not to pole vault don't pole vault the Peruvian caldera, folks. In fact, don't pole vault any caldera. It could be bad for your health, and we need the views. Today's featured product is the Do Not Pole Vault the Caldera tank top. You can link to all of that sort of stuff at smAshomash.com. That's the smAsho merch shop. And we see an American earthquake swarm here, although no major earthquakes happening in the U.S. It looks like nothing over a 4 magnitude here. So let's see what else has been going on. A 6.0 magnitude happened in the Kermadec Islands region, northeast of New Zealand, around the Kermadec Trench there. That, I believe, is the largest of the past 24, and we see a couple aftershocks there of 5.2 and 5.4 magnitude. So we see some deep quakes under Denali and Idaho, and the Geysers, California, Pleasant Hill, California. These are all like in the 2 magnitude range. Also a 5.6 aftershock there in the Kermadec Islands. Deep quake in western South America at Argentina, as well as one around the same time here in the Bande Sea. That one at 2350 Universal Time. The 4.6 at Argentina at 2314. So just about a half an hour apart. Two deep quakes, quite distant spots on the planet. Quite different latitudes as well. Also a 5.1 at Vanuatu was a deep quake, and a Mexican deep quake. And those happened only 6 minutes apart. Also on opposite sides of the equator in this case. So a bunch of quakes in California. And we're going to zoom in on the U.S. real quick here after we get to the top of the list. A deep quake in Indonesia at a 5.0 magnitude, and a deep quake at Peru. Also a 3.0 at Summit, Utah. So here's a zoom in of the U.S. map. Quite a few quakes there, especially around Western California. And let's continue on. We don't want the video to be too long, and there's still lots of stuff to cover. No major solar flares over the past 3 days. Only mild X-ray activity there. And no proton strikes as measured by the GOES-16, and no surprises to this channel. What say you? Here's 3 days of the GOES magnetometer, and we're seeing a little smoother readings here. The Earth is solidly in a South Pole current sheet. Here's a view of that. It's the polarity of the heliospheric current sheet, folks. You know, the sheet of current constantly coming out of the sun in the form of mainly hydrogen nuclei, otherwise known as solar protons, whatever you want to call them. Again, Earth solidly in the South Pole current sheet, and there is a possibility for coronal mass ejection, so don't be surprised to see us pipe up with another video about a coronal mass ejection if and when one releases. Sometimes they collapse back onto the corona or chromosphere, but, you know, that's why we're working on being able to forecast them. Let us know in the comments if you know anybody else able to forecast coronal mass ejections before they happen. Here's a line of sight coronal hole plot, and we don't really see any features here, although we do see one thing interesting happening. We see the B field being pulled down here toward the south, an indication that the solar polar field reversal process is progressing here during cycle 25. Here is the line of sight ecliptic plane field plot, and this also shows you with that blue line the extent to which one field is ruling over the magnetism on our part of the current sheet. So hopefully that helps you understand things. The green and red portions are the north and south pole portions of the current sheet respectively. So this is the North Pole, obviously. This is the South Pole. And the blue line represents the extent to which one or the other is contributing to the total field detected here at Earth, otherwise known as the BT on the real-time solar wind. We'll get to that momentarily. And we did see a brief period of geomagnetic storm here, a G1 KP5. G1 geomagnetic storm of a KP5. And for you new viewers, the KP index is a measurement of global geomagnetism. Here's the real-time solar wind data, which did exactly what we forecasted yesterday. The solar wind density dropped off, and the solar wind speed came up to about just over 500 kilometers per second, now subsided a little bit down to 480 approximately. Current solar wind speed 478 kilometers per second. Current solar wind density 4.75 protons per cubic centimeter, and the other factors such as the BT/BZ and phi angle and temperature not particularly noteworthy. Here's 4 hours of pressure data. Really, it's a model based on the space weather modeling framework. It's our geospace magnetosphere movie. And as you could expect to see from the solar wind, the last 4 hours here are fairly consistent. You may see a mild drop-off here in the pressure over the past 4 hours, and indeed you do. Next, ground magnetic perturbations. And here are those. Let me bring this back to the beginning. We don't expect to show you very many ground magnetic perturbations, but we show this daily anyway. due to the geomagnetic excursion currently happening on planet Earth. So geospace delta B would be changes in the Earth's B field. And we've put all the magnetism portions of the video sort of in the same section. It helps our viewers to understand how these things relate and does not propagate any nonsense about magnetism. Now, we do regularly stream to Twitch. This video isn't currently streaming to Twitch, but we are going to stream to Twitch momentarily during our cosmology segment. Have you seen our take 3 for Fauci Shut Up 3? Here's a clip. We just uploaded this one yesterday.
You're a fraudster, yeah. We hope everyone knows.
It's Shut Up Fauci Part 3. Shut Up Fauci 3 featuring Henry and Al. Thanks to our YouTube subscribers, by the way. Don't forget to press like and subscribe. Press that share button. Tell your friends, foes, science noobs, and science pros about the channel. And also don't forget to subscribe over on BitChute, as there is exclusive content over there, such as our dumpster fire train wreck video about the DNC and other things like our 400 subscriber special over on BitChute, thanks to our subscribers over there. And now we are going live. And it's for our cosmology segment. So welcome to our Twitch viewers. We've been streaming cosmology segments live lately, and we're continuing on with that today. So today's cosmology segment is going to feature some interesting stuff. We're going to head into the subatomic world for a quick moment. But first, I'd invite everybody to check out our own website, smAshomash.org, smAshomash.com, and all of the links therein. Today's featured cosmology segment product is the Condensed Matter t-shirt. So this one, if you actually click on Smash Store here, we've got actually 3 merch shops: smAsho merch, smAsho store, and Smash Store. This is Smash Store. And if you check out the featured products here, they're largely astronomy, cosmology based. Today's product is the Condensed Matter shirt, which is incredibly high resolution, by the way. In purple, yes, Team Purple. Shout out to Veloshop, theveloshop.net. And let's talk leptons. There are 3 kinds: electron, muon, and tau, as well as the neutrinos, electron, muon, and tau neutrinos, and of course antiparticles, leptons. If you don't know about them, I don't know, have a read. So electrons and muons are what we're going to be talking about, and muons are coming up on the list. So a muon is a bit like an electron, except with more mass, and the way this fits into the standard model is, well, under dispute currently. So I'll just let this scroll for a quick moment here. Muons, they're relatively non-interactive, folks, and they're detectable thousands of meters below the Earth's surface. And without continuing on with that, let's talk more about muons. But before we do that, I would invite everybody to check out Unziker's Real Physics. So here's a little dissertation Unziker did here about why particle physics is stuck in a dead end. Perhaps check this one out. Also, check out his video on alpha decay. Alpha decay is a very strange thing, folks. And when you realize what neutrons do when they're hanging out, when neutrons are bored, they do strange things, and I won't get into it, but here's a quote.
Fourth quark generation and so on. Many black holes, extra dimensions, gravity in your face.
Gravity in your face. And so we've got 2 conflicting results here about muons. Does the muon's magnetic spin moment fit just fine into the standard model of physics, or does it not? We've got 2 articles from the same publisher, SciTech Daily, who is going the extra mile once again to show us the conflicting data here. So here is an article about how at Brookhaven they've proven that the muon fits perfectly into the standard model in terms of the precession of its magnetic spin moment. You can't make this stuff up, folks. And guess what? Here's another result showing that it's well off. as resulted by the Fermi Lab, well off of the, the standard model. Another article on the same publisher. So this should be interesting as this plays out or doesn't play out or just leads to more confusion. As we've been saying for a few years on the channel, physics is being rewritten before your very eyes, folks. And anyway, a muon is 200 times as massive as its cousin, the electron. And without getting too in-depth into this, since it's a cosmology segment, check out the article. You can find both of those on scitechdaily.com. scitechdaily.com. All right, and let's continue on here. There's nothing random about Cygnus X3. We talked about it earlier, the star Deneb, which just happens to be the brightest intrinsic object visible from our solar system. It puts out X-rays, and it's one of the only known cosmic ray point sources. But in any case, here are the X-ray outputs of Cygnus X3, the star Deneb. And it's actually in an X-ray loud state right now. We saw as a result of this emission right here, we saw the entire graph get expanded. Here's the 30-day graph, and you can see, again, it is in an X-ray loud state right now. We would be delighted if Lofar would take a look at this. Hey, Lofar, if you're watching the video, please fix your radio telescope on Deneb during its X-ray loud state. Anyway, here's the 16-year chart of Deneb's outputs. And I won't say anything else about the cyclicity, periodicity, and importance of this particular star, but if you'd like to read all about it, head to smAshomash.com/forum. There's a whole forum thread in the Cosmology Forum about Cygnus X3, which is also a celestial pole star at the other end of the precessional cycle of Earth's axial tilt wobble. And let's talk about Mars Perseverance. Mars Perseverance is about to fly its helicopter, folks. It's going to be a good time. And in the process of preparing to do so, it's taken 62 pictures. It's had 62 pictures taken. And if you want to check out this article, it's on space.com, which is basically NASA's... Let me refresh this. It's basically NASA's website. How could it be basically NASA's website? Anyway, here are some imagery. Here are some images. Here is some imagery. From Perseverance rover's selfies. And these were stitched together by a citizen scientist here. And there's a close-up of the helicopter, which should be taking a flight soon. It's got giant blades because the atmosphere of Mars is extremely diffuse. It's very lightweight, and its solar panels are a go. Let's talk about Lofar. Lofar is a telescope consisting of about 70,000 radio antennae across Europe. And they've done a massive survey of old galaxies. And we're seeing some incredibly interesting features, such as these. Massive astrophysical jets located at billions of light years distance. Radio telescope Lofar reveals thousands of star-forming galaxies. And I won't get into whether or not these are really, quote, star-forming and, quote, galaxies or not. I'll just show you the fantastic imagery. Here's a massive radio source believed to be a, quote, black hole, end quote. As we try not to offend anybody when it comes to the realm of science, which becomes more and more difficult as more stuff is understood. Anyway, these are the locations of Lofar. If you're not familiar with Lofar, again, it's 70,000 ground-based radio antennae located in Europe. It's the low-frequency array, and it's a massive, massive radio telescope connected by a fiber optic network. This one appears to have a partial moat around it. Seems like a good idea. I don't see a drawbridge, though, so it looks like it's still in its construction stages. You can read all about it at astron.nl/telescopes/Lofar. And that's today's cosmology segment. Thanks to our Twitch viewers, etc. Again, I've been your host, Dan, a.k.a. smAsho. Wherever you viewed the video, don't forget to press like and subscribe. Leave us a comment. And again, please share the channel with your friends, foes, science noobs, and science pros. Let's continue on, as there's more stuff to cover, like electron flux. And we're seeing pretty low levels here. Here's the one-year chart as reported by Solon.info. Here's a 3-day chart of the greater than or equal to 2 mega electron volt electron flux as measured by the GO-16. No surprise there, we see a coronal hole wind stream happening. Here's the forecast. We're expecting an uptick, and I would expect a little higher uptick than what this forecast has, I'll say, there. The green boxes are the forecast, and the yellow diamonds are the observation. Here's a diagram of the Van Allen belts. Feel free to pause if you must. Here's the total electron content forecast. And we can expect to see some very chaotic electron flux here, actually. Some sudden bending of the bands, folks. The Van Allen belts saw a bend happen. I'll let it play through again. Right here, we see a very high level of electron flux in the central Atlantic Ocean off the west coast of Africa, right around this area. And then it suddenly shifts north. It's all a result of the North Atlantic anomaly, folks. In any case, continuing on, and by the way, we do typically see more chaotic electron belts during times of coronal hole wind streams. And I won't further elaborate on that. I don't want to give away too much of the astrophysics in any one video, because we want you to watch the other videos as well. Here's a diagram of the atmosphere, showing you things like the troposphere, where all your weather occurs, and so on. And I've forgotten to shut down the cosmology segment. See you later, Twitch. All right. Next, a map of the ionosphere. And we can expect to see some anomalies here also, considering the connection between the electron flux and the ionosphere. The ionosphere is located basically at the bottom of the inner Van Allen belt, folks. It's where the denser part of the atmosphere starts to interact with the plasmasphere. And indeed, you can see some anomalies here happening in the Central Pacific Ocean as well as the Atlantic Ocean. Really over the Atlantic Ocean. This is at an altitude of about 300 kilometers. The F layer is right here, around 300 kilometers. And keep in mind, folks, the increased pressure from the increased solar wind speed does affect the altitude of the ionosphere, if you were wondering. Anyway, here's the latest image coming in at 9:30 Universal Time. And let's go live again for some meteorology stuff. So we've decided to go live a second time here on Twitch. So welcome back, Twitch. And it's for our meteorology segments, as they have some value in a live state. I would note this extremely powerful and very large low-pressure system located in the North Atlantic here, sort of off the coast of Cape Cod, but like 1,000 miles off the coast of Cape Cod, is still affecting the weather every place east of the Mississippi. So this is causing a suction, and it's causing higher pressure weather, which is practically everything to move in this direction. And it's also causing all kinds of anomalies in the North Atlantic. These are the surface winds, as reported by nullschool.net. So here is the 250 hectopascal winds that we normally show, and you can see that counterclockwise rotating system translating all the way into the jet stream level flow. It's a very powerful low-pressure system. And it's making for some rough seas in the North Atlantic as well. Anyway, here are the jet streams of the eastern world. And here are surface winds. And a very powerful low here down by Antarctica as well, southwest of Australia. Not too far from the South Geomagnetic Pole, actually. And a couple other fairly powerful systems here. Not worrying too much about the Himalayas, but this area here near Kamchatka, some very strong winds at the southern tip of Kamchatka there, as well as off the northwest coast of Australia. 3 different powerful rotating clockwise low pressure systems out there. Next, looking at windy.com, here are the pressure maps of planet Earth. And here's the GFS forecast for where they'll be tomorrow at 12 noon Eastern Time. And we're located in Lehigh Valley, Pennsylvania, right about there. About there, folks. And we've got some heavy rain forecasted, some severe storms here as a result of jet stream, cold air interactions, and so on. Here's the total accumulated precipitation forecast, and we're expecting quite a bit of rain here, especially in the Florida Panhandle. This is through, that is through 1800 Universal Time on Sunday, April 11th. So forecasting for like 6 inches of rain there, 6 or 7 inches of rain there in the Florida Panhandle as of now, according to the GFS forecast. Next, lightningmaps.org. Here's your real-time lightning map. As we continue on with a meteorology segment. And we are streaming live to Twitch right now. Thanks to everybody that viewed the video wherever you viewed it. It's lightningmaps.org, by the way. Lightningmaps.org is where I go when I hear thunder. And we've got terrestrial lightning. Shout out to Slidell. Hey, Nolans. There is some serious thunder rolling in Nolans. Check it out. This one happening right by the airport. There's a series of 3 bolts. And if you have a view of this storm from a distance of about 80 kilometers, go take time-lapse imagery of the cloud tops. You may see some things you weren't expecting. Sprites and green elves and green goblins and possibly even Nibiru. Here is the U.S. Doppler Radar Map, and you can see this entire system rotating here. And it's causing some stagnation and some training to happen as well. Training, by the way, folks, is when a storm tracks in the same direction as the line of storms, where you get the same storm happening. The same areas hit over and over again. So a pretty violent series of weather happening down there, especially in places like Louisiana, Mississippi, and Alabama. Also some strong storms around the Great Lakes region and in the Great Plains. Here's what's going on in the cloud layer. Then you can see Nibiru moving here in between the GOES and the Earth. Or is it a Borg sphere? Leave us a comment. Let us know. Maybe it's I know. Maybe it's a plane spraying chemtrails in the stratosphere. And here's the water vapor map. This should give you some insight into how this moisture is going to move. We're actually going to zoom in on Louisiana here because it's pretty severe weather down there. So let's just see if we can show folks a little bit additional data. We hope your power is on. And we'll zoom out a little bit. There we go. Great view of those clouds. You've got actually 2 interacting systems here. You've got a bunch of low clouds over the Gulf of Mexico. Fantastic view of that moisture there. And you can see it's going to be moving a bit to the east. So it's going to have an almost due east trajectory here, and it's all getting a push from that dry mass of air on the left of your screen. Fantastic view of that. You're getting serious pressure gradients happening in that area. And it's all being pulled to the southeast as a result of that extremely powerful low-pressure system off the coast of Cape Cod. It's affecting all of this weather, folks. Believe it or not. And that's where we'll have to end this second Twitch stream of the day. And again, you can view our live streams at twitch.tv/smAsho if you like. It's time for bonus features, which are going to consist of the most recent hydrogen alpha imagery. How about El Teide, Spain? And check it out. We see the filament actually moving around here. You can see this filament that we're about to show more imagery of, kind of suddenly jerking to the west. Looks like some missing data there. Nothing to write home about, folks. And we're also going to show you the ultra high res images of the sun. First, I'd invite you to head to smashomash.com, check out our links, and support the channel. By the way, if you'd like to become a patron, you could become a patron for the month of May by winning our slam poetry contest. All I got to say is, people aren't free, but the Patreon membership for May is if you win the slam poetry contest. We encourage you to write. That's free too. Has your governor freed you? Do you need to get permission, or will you ask forgiveness? Do you make it happen, or are you too concerned with receiving free shit? Thanks, Smash Team. By the way, for tuning in, leave a comment. Let us know what you think about whatever we talked about, since there was plenty of subject matter. Thanks to our patrons, especially our new patrons, as well as our old patrons. And our medium, thanks to all of our patrons. Our patrons are the true source of funding for our content as we make just this side of nothing for the videos on YouTube. Thanks to YouTube for the great algorithmic treatment. And pardon the sarcasm, viewers. Here's the ultra-high resolution magnetogram and solar intensitygram to show you, I think, 0 sunspots. I don't see any ombre. Do you see any dark spots? I think I do see a dark spot. We could see a sunspot forming there in the southeast. So if that remains for 12 hours, folks, you could see a sunspot. Otherwise, I don't think there are any. And let's take a look at some more close-ups before I vanish. We've got some more close-ups of that active region in the northeast. So that filament that we were just looking at, some fantastic imagery of it here in 304 angstroms. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. Seriously, don't drive. And certainly don't drink and drive. I mean, that's, do I even have to say that? I guess I do. Don't pole vault the caldera, and don't drink and drive. But whatever you do decide to do, thanks again for tuning in, and may that solar wind be at your back. And we could actually see a coronal mass ejection happening once again as we made the video.